Hi guys, and welcome back. Today's lesson we're going to be looking at the reactions of metals with metal oxides, metal hydroxides and metal carbonates, which is from topic 4 in the AQA GCSE chemistry 1 to 9, and it's in part 2 of topic 4, which is the reactions of acids. And what we're going to look at today is we're going to have a look at the reactions between acids and a metal and metal compounds. We're going to look at the names of the salts formed in these reactions, how we get those names, and how we can make a pure, dry, soluble salt by reacting an insoluble salt with an acid, which is a required practical 1 if you are doing the the triple chemistry. And then we'll also look at the test for hydrogen and carbon dioxide. So starting off, acids and metals, these always produce two things when they react. They're always going to produce hydrogen, gas, we'll see that coming off as bubbles, and also a salt, just like the salt you put on your fish and chips, but not necessarily exactly the same type. And we have a general reaction, which is metal plus an acid makes a salt plus hydrogen. And you are expected to know this equation, you are expected to be able to use this equation with any given reaction, okay, involving any metal and acid. As I said, hydrogen's a gas. You're going to see that fizzing and bubbling, and that's going to, how much of that you're going to see depends on the metal, because some metals are going to react violently, like the ones in group 1, potassium, lithium, sodium, so on. Some of those may even react explosively with an acid. Some metals are only going to react with a strong acid or a concentrated acid, and even then slowly, for example copper. And some, like gold, don't react at all. It is possible to get gold to react with acids, but you have to mix sulfuric acid and nitric acid together to make something called aqua regia, and that's very, very powerful reagents for dissolving gold, and it doesn't actually dissolve it because of the acidity, it's something else. Now, we've talked about salts. So a salt is basically a metal with something that's not a metal attached to it. They are ionic compounds, and it's really easy to name them from an equation. For example, the first part of the salt name will always be the name of the metal. For example, what you put on your fish and chips, that salt is sodium chloride. The first part of the name is sodium. It's the name of the metal. But it could be iron, it could be zinc, it could be magnesium, it could be literally any other metal on the periodic table. The second part of the name depends on the acid that's reacted with the metal or the metal compound, and you have to learn these, and it's fairly easy as well once you've seen them. Okay, so hydrochloric acid is going to make a chloride. You can see it's got the chlor part from the chloric, except it ends with IDE rather than IC. Sulfuric acid, that's going to make a sulfate, and again this time we've got 8 on the end of sulf, and you can also see this spelt SULFATE. That is also correct. And lastly, the other one that you need to know for GCSE is nitric acid is going to make a nitrate. You will notice that sulfate and nitrate are very similar. They both end with 8, ATE, and this is because there is oxygen present in sulfuric acid and nitric acid. There isn't in hydrochloric acid, so that's why we don't see 8 on the end. So this means if we were to react a metal, for example zinc and hydrochloric acid, the first part of the salt name will be the metal name, for example zinc. The second part comes from the acid, and we've said hydrochloric acid gives you a chloride, so chloride will be the second part. You put those together and the name of the salt is zinc chloride. Really easy. Okay, and you can write this out in a word equation. Zinc plus hydrochloric acid makes zinc chloride, which is our salt, plus hydrogen. And we can put that into a symbol equation where Zn plus HCl makes ZnCl2 plus H2, and put the video on pause and see if you can balance this equation and add the state symbols to this. Okay, bearing in mind what zinc is. So put the video on pause now and then we'll have a look at the answer. Okay, so there's our equation. When we balance it and add the state symbols, what we get is Zn solid, zinc solid, it's obviously a solid, it's a metal, plus 2 HCl, and this is aqueous, so AQ for aqueous, it's dissolved in water, makes zinc chloride, which is also aqueous, plus hydrogen H2, which is a gas. Another example, we might get magnesium and sulfuric acid, and again the salt name is magnesium sulfate. We take magnesium from the magnesium and the sulfate from sulfuric acid, join those together, magnesium sulfate. And again we can create a word equation, magnesium plus sulfuric acid makes magnesium sulfate plus hydrogen. Don't forget the hydrogen. Metal plus an acid is always going to make hydrogen. And then we get our simple equation, Mg solid, magnesium solid, plus H2SO4. This is sulfuric acid. You should know for GCSE, you need to remember that H2SO4 is sulfuric acid, and that's aqueous, and that makes magnesium sulfate, MgSO4 plus H2. Now you can work out the formula of your salt, and you can work out whether it's going to be MgSO4 or Mg2SO4. You can do that using ionic bonding. Okay, here's some for you to try. Potassium and nitric acid, iron and hydrochloric acid, and uranium and nitric acid. Create word equations for those. Put the video on pause and give yourself a little bit of time to do that. Here are the answers then. Potassium plus sulfuric acid makes potassium sulfate and hydrogen. Iron plus hydrochloric acid makes iron chloride and hydrogen. Uranium plus nitric acid makes uranium nitrate and hydrogen. So now we're going to move on to metal oxides, metal hydroxides, and metal carbonates. These are all bases, okay? And a base is going to react with an acid in a neutralization reaction. They're basically the opposite of an acid. Some of them, especially some of the hydroxides, are soluble, and that means they form alkalis when they dissolve in water, because an alkali is something which forms OH minus ions, which you will remember from the lesson on acids and bases. All of the following, all of the oxides, hydroxides and carbonates, they're all going to react with acids to form a salt plus water. Carbonates, though, are also going to produce carbon dioxide. So some examples. A metal and a metal hydroxide plus an acid is going to make salt plus water. For example, sodium hydroxide plus hydrochloric acid makes sodium chloride plus water. A metal oxide plus acid makes salt plus water. For example, magnesium oxide plus sulfuric acid makes magnesium sulfate and water. And a metal carbonate makes salt, water and carbon dioxide. So we get this overall equation, calcium carbonate plus nitric acid makes calcium nitrate plus water plus carbon dioxide. And again, the salt name comes from the metal and the acid used, just like it did in the previous examples. So here are some more for you to try. We've got calcium carbonate plus sulfuric acid, zinc carbonate plus nitric acid, zinc oxide plus hydrochloric acid, and lithium hydroxide plus nitric acid. See if you can work out what they make. Again, put the video on pause, work out what the answers are, and then when you've got the answers, then replay the video. So here are the answers for the word equations. We've got calcium carbonate plus sulfuric acid makes calcium sulfate plus water plus carbon dioxide. Number 2 makes zinc nitrate, water and carbon dioxide. Number 3, zinc chloride and water. And number 4, lithium nitrate and water. And now we'll have a look at the symbol equations. So for the first one we get CaCO3, which is calcium carbonate. The CO3 is the carbonate part. It's a solid that reacts with sulfuric acid, H2SO4, which is aqueous, and it makes calcium sulfate, CaSO4, plus H2O plus CO2. Okay, and you can see here that the carbon and 2 of the oxygens have come to make our carbon dioxide, and the other oxygen has come and joined with these 2 hydrogens to make our water here. In our next example, we get ZnCO3 zinc carbonate plus 2 nitric acids, HNO3, and that makes ZnNO3 2. So we've got 2 NO3s attached to the zinc, which is aqueous, plus the water, plus again carbon dioxide because it's a carbonate. In number 3, we get our zinc oxide, ZnO, plus 2 lots of hydrochloric acid, and that makes zinc chloride plus H2O. And we can see here the 2 hydrogens from our acid are joined with the oxygen from the zinc oxide to make our water. For lithium hydroxide plus nitric acid, lithium hydroxide is LiOH, nitric acid is HNO3, and lithium nitrate is LiNO3, and water is H2O. And this time we can see that we only need one acid, unlike two for the zinc oxide, because the acid provides one hydrogen in the water, and the other hydrogen in the water comes from the OH on the lithium hydroxide. Okay, now we need to know tests for the gases. Okay, you need to be able to tell whether the gas made is hydrogen or carbon dioxide in these reactions, and therefore there are two tests we can do. The first test is the hydrogen test, the squeaky pop test. And what you do is you capture the gas that you think might be hydrogen in a test tube, then you get a lighted splint and put it into it. And essentially what happens is there's an explosion and you get a squeaky pop noise, which sounds a bit like whoop. Okay, a little bit like that. Okay, you can probably find videos of that and do it in class when we're not in lockdown. The test for carbon dioxide is lime water. What you do is you bubble the gas through lime water, which is something called calcium hydroxide. It's nothing to do with the fruit. And if it turns cloudy or a milky colour, that means carbon dioxide is present. And you've probably done that in primary school, and you've certainly done it in secondary school. Now, the required practical that comes with all of this is making a soluble salt. It's required practical 1 on AQA GCSE chemistry. And what happens in essence is we use a neutralization reaction between an acid and a base to create a soluble salt. We then filter it and crystallize what we get to separate the dry solid product, okay, the soluble salt. We normally use an excess of our starting salt, and we do this to make sure all the acid has reacted. It's hard to tell if all the acid is reacted because acids tend to look like clear liquids and water tends to look like a clear liquid, so it's hard to tell if you've got an acid or water. So the way to do that is to make sure you add lots and lots of your base, which is going to react with your acid, until no more base reacts, and that means all the acid has reacted in theory. So in excess, what that means is we've got more of it than the reaction needs. And you can work that out by something called the reaction stoichiometry, which is a rather complex word. It basically means the number of moles in the equation, the symbol equation for the reaction. So, an example is you might have magnesium oxide, which is an insoluble salt. It's white, it does not dissolve in water. And you may need to make magnesium chloride, which is a soluble salt. You could also use for your insoluble salt here, instead of magnesium oxide, you could also use magnesium carbonate. So, to make the magnesium chloride, you're going to need to react it with an acid. And we're going to need to use hydrochloric acid in this case because we're making a chloride, and you'll remember from the names of the salts, it's exactly the same thing. We're reacting an oxide with an acid. If we want to make a chloride, we're going to need to use hydrochloric acid. And the equation we get is magnesium oxide, which is a solid, plus hydrochloric acid, aqueous, makes magnesium chloride aqueous, plus water, L. Water's a liquid. Always remember that, it's not aqueous because water doesn't dissolve in itself, it is the thing that does the dissolving. Simple equation for this, MgO, solid, plus 2 hydrochloric acids, HCl, aqueous, makes MgCl2 plus H2O. And you can use this simple equation to work out how much magnesium oxide and acid you need to react. Okay, and this goes back to topic 3 moles. So you might, for example, say you're going to use 100 milliliters of 1 mole per decimeter cubed hydrochloric acid. You can work out how many moles are in that. You can then look at this equation and realize that you're going to need to make this reaction go completely, you're going to need half the amount of half the number of moles of magnesium oxide as hydrochloric acid. So you probably want to use it in excess, use like 1.5 times the amount that you should do of the magnesium oxide. So in other words, adding 150% in. So you're going to make sure that all of the HCl is reacted by overloading the reaction with lots and lots of magnesium. If you're unsure of that, please go back to the videos on topic 3 on moles and concentration and look at those, and that'll explain more about that. Or alternatively, you can pop a question down in the comments and I will try and answer it in a timely fashion. So we need to know a method for this, and you will hopefully have done this in school or will do it in school at some point. So the first step is to pour 100 milliliters of 1 mole per decimeter cubed of hydrochloric acid into a beaker. Now, some important parts here is in the mark schemes for if it asks you to write a method for these for a 6 marker, it will ask you to, or it will need you to see for the top marks talking about how much you're going to use. So for liquids we're looking at a volume, and for an acid here we're also looking for a concentration, although that's less important than the volume. It's just got to be a realistic amount. You don't have to use 100, you could use 50, you could use 10, so long as it's something that's realistic and sensible, so long as you're not saying I'm going to use 50 litres of acid or I'm going to use 0.0005 millilitres of acid, because that's just stupid and you know, isn't going to fly, and you would lose the mark for that. But 100 mils is fine, so put 100 mils of acid into a beaker. Then we're going to add the magnesium oxide and stir it until it dissolves. Once it's dissolved, we're going to keep adding more magnesium oxide until no more reacts, stirring all the time. And this is going to make sure all the acid has reacted. This is going to make sure our magnesium is in excess. Okay, important stage there. We need all of that acid to react, because otherwise our product may not be pure. The next thing, we're going to set up a filter paper in a filter funnel, put it over something like a conical flask, and we're going to filter the solution to remove the unreacted solid, to remove the unreacted magnesium oxide. This will then leave us with the magnesium oxide in the filter paper and a filtrate in the bottom which contains our soluble salt, so soluble meaning it dissolves. We can then pour that filtrate, that solution, into an evaporating basin which looks like a bit like a cereal bowl, ceramic cereal bowl, and we can heat it gently over a Bunsen burner to evaporate off some of the water. Okay. We don't want to boil it dry, we just want to heat it gently to evaporate some of the water, and then we can leave it somewhere warm for the rest of the water to evaporate. Then we can collect the solid crystals of our soluble salt, and you can dry those further in an oven or in something called a desiccator, which normally contains a chemical which absorbs moisture, and then you've got your dry crystal. And you could prove they're soluble by putting some in water and stirring it, and you'd find it would dissolve. So, we often get common exam questions about this, and they involve talking about the method and suggesting why it's important to use an excess of the solid, and that is there to make sure all the acid is reacted. They also want to make sure your method is in a logical order for full marks, and it contains volumes or masses of compounds if that is appropriate. Again, think about it logically. You've got to work your way through it for the top marks. You've got to really know your stuff about the practicals. So the practicals you've got to really take seriously in science and chemistry. Alright, summary time. Acids react with metals, metal oxides, metal carbonates and metal hydroxides. All of the reactions produce a salt. The first part of the salt is a metal name, the second part depends on the acid, and you will need to learn those rules. Metals produce a hydrogen and a salt with an acid. Metal oxides and hydroxides produce water and a salt. Metal carbonates produce carbon dioxide, water and a salt. Squeaky pop is the test for hydrogen. Remember, it's that whoop kind of noise. Lime water turns milky. That means you've got a carbon dioxide. And the required practical involves 3 main steps. First, react the acid and the base to make the salt. 2, filter the solution. 3, crystallize our new salt. Right, thank you very much, guys. Please remember to drop a subscribe and a like as well. That really does help. And if you've got any questions, please leave them in the comments below and I will try and answer those as soon as possible. Okay, look forward to seeing you soon. Take care. Bye-bye.